Good have kept it, they got 7 more with it.
Yeah.
Alexander Hamilton, I will be. Well, not really be. I like how history teaches him he was actually gay. Very wonderful. He had relations with his slave. So I was mad for the time for 2 reasons. Being gay, but history is so fun, isn't it?
I
That's how we
mean,
feel for math.
it's my thing. I mean, I can look at it sometimes. And some parts, it's interesting things you can learn from.
Oh, front row.
But yeah, sure, of course it's interesting.
A bush needs to be all the way over there.
Which bush?
Second bush. Autism.
Comic relief. Real comic relief.
He had a rough presidency. I think we can all agree on that. What's his cabinet? Nixon would be kind of there.
Yeah, I get myself in trouble if I talk about politics too much.
Yep.
On that, I made that mistake.
I think professors need to tread lightly when it comes to that.
Yeah,
I criticize everyone equally. Say that.
well, you know, the funny thing about politics is that I have very strong opinions, which I want to share with you guys. But they're all kind of off. like, I mean, there really is a lot of like malfeasance on all sides. So there's room to criticize all of them. If you want to just take that stance.
Sorry about my siblings, they just like yesterday. But, right, so.
What's happening? Where's everybody? Come on. It's
Friday.
it's all kids.
Last
A
night-
work day.
Last night-
Right, because we have like a 3-day weekend or so. Do we have a 3-day weekend? Well, my kids do. They have
Is it Monday,
President's Day,
President's
right? Yeah, you guys, I thought that was what this was about.
No.
Just
Well,
random
15
president.
is
Okay.
I just like talking crap on politicians. I'm an equal discriminator.
Well, this is like a dangerous participation grade, you know, situation here. Okay,
This is a study group.
this is pretty, well, thank you.
We could use this day to go over.
Over some, what?
Over everything.
Over, we could
Just kinda do
review,
like a recap, just so we're.
I don't mind reviewing a little bit and talking a little bit about some of the homework. That's fine. I can do some of that today. And then I'll just talk, because these sections, I'm gonna be honest with you, like, I'm not like qualified to teach this stuff. Like, this is not what I got a PhD at a top 5 school to do. Like, I really,
Why would they say? Yeah.
I mean, I just,
They just.
They-
Oh, yeah.
What did you do
did
wrong?
not have a choice.
I don't know, they
Would
punished
you
me.
say no?
I just don't, I mean, I'm reading it, but I'm like, I'm reading it like you guys can read this, and you should read it.
Because none of the math tutors.
It's not, there's not a lot of math. No, I can do the other stuff, like the graph theory, I'm qualified to teach. This section's on where it's like, they're talking about statistics, but not like math. They're talking about like studies that were done and things like that. And okay,
See, that's where you-
I mean, I'm learning that I can read that and understand it, but I don't know how to teach that to you guys. I'm honest, I'm just being honest. So I would recommend, we'll talk about it. We'll work through this, and when we get to the math, which I think is the next chapter, where there's a little bit of math, I can help more in that situation. But I just,
I just suck at making this.
that stuff we can figure
There's
out. That stuff I can
there's
help
a
with.
few of us who've gone to tutoring.
Uh-huh.
And none of them are really.
So
No
the
one
first
knows.
order of business for today is to talk about a problem set, our problem session that we can set up this week, get a
Oh.
schedule for that. So I know I have several people online. So I don't know if they can hear me. I think they can, but they can put in the chat any kind of input they want. And so what I want to say is I'll do it like this. I'll format it like this. So we'll have like people can come in, and I would like people to come in, but I'll also have like a Zoom thing. We'll record it and post it and everything. So everyone can get a hold of it. Now, let's see. I have a schedule I'm going to look at. I was looking at it earlier, but I don't want to. Things kind of shift around on my stuff. So let me see. I would like it to be like a Monday, Wednesday, or Friday, in the afternoon at some point.
What time? Yeah, what time?
What time? That's what we need to figure out.
I have class back to back to back
Back to back to back
So
all
I have to
afternoon.
work.
until 3:30.
Yeah, I can do after work.
Okay. Okay, so 3:30. Sorry, guys, I'm just how about we do 3:30 on Friday? Oh, everyone doesn't like that because it's the, okay, how about Monday? 3:30 Monday.
Oh, no. Wait. Can you? We're not having more live sessions anymore.
The people in this room are most important. Okay, not, sorry.
No offense.
No offense, Ava. No, you guys are important too at home, but I want to, like, I would love, it's really hard for me to do a problem session and not have anyone come, like in person. Because then I'm just like I'm in a room by myself talking to like nobody and then writing on this, like, yeah, I do look crazy. And it's not just looking crazy, it just feels a little bit, it doesn't feel like it doesn't feel right. So I would like people that are here in particular to give me a good time, and the people that are, so you can watch recordings and so on. And I have a rule that if people don't come, I stop doing it. Okay, like, okay. So Monday at 3:30? Okay. Are you guys, you have time?
Can you
Okay.
send out like an announcement to remind us?
I am going to, because I'm gonna have to get a room. So I'll reserve a room and then I'll send an announcement with it. Okay. This will be review or problems. I don't want to just do them for you though, but we'll work through them. I mean, I won't hide the ball either and be like, here's a similar problem. We'll work through them together. Okay, good. All right, let's talk then a little bit. So there was one problem that I got some emails, and I'm sorry, I've forgotten the student's on her phone name. What was her name? Mikayla. Okay, great. Yeah, so Mikayla sent me an email, or no, it came to my office and we talked about this problem. What was it? It was 64 of chapter something, like 8, 9. Chapter, guys. Chapter 8. 8? Sorry?
I was just saying that I didn't do that one.
Okay.
I legit guessed. I wrote on a random card.
Just
So you know. It's wrong.
If I don't even do a problem, it's probably I'm not telling them to break down. I don't that's it.
Yeah.
So it's,
Pretty
so,
much, yes.
so it said you have like tasks 1, 2, 3, up to N. Is that right? And then it said they're independent tasks, meaning there's no precedence relations. And it said you have 3 processors. I'll find the best schedule. Optimal. I'm paraphrasing. Oh, sorry, Chad. I hope everybody who can hear me at home, that time is okay. You'll be able to. So I also, I might not, probably will have a different link also for those that are zooming in. So I'll put that in the announcement. All right. So who, aside from Michaela, sorry. Okay. Who aside from Michaela knows how to do this problem? Knew how to do it, figured it out. Okay. Right. So let's make, you know what, I'm just gonna, I just like rely on previous work here. Not bad. Yeah, I actually put a lot of work in preparing notes for this class. It's a lot more than I expected. Okay. All right. I know. Thank you.
Come on.
Oh, wait, actually, I have one with 3. I was going to extend it. You're right.
Just make
That's
sure
why I
you're
was so
qualified.
confused. 'Cause
You have a whole chest holder.
I have the whole test full. Yes, I do.
Right there.
I need one that's blank. Or is this green? Green. Ah, no.
Oh,
All right, hold on, let's see if we can. Mess it up. I think I can. I think if I move this. No, I can do it. Ah, guys. So.
It's not been nice to you.
This must stresses me out most, but it gives me the most joy.
yeah.
That's,
I mean, it's
It's
math.
good.
I'm
it's
glad they give
fun.
you joy.
This is definitely a good place.
I mean, I really don't want you to take any of this stuff seriously. That's for sure.
You are.
I think I'm succeeding with that one.
I'm in this class for the credit.
No, I mean, I know that. Like, it's not like I've, this is my first rodeo here.
You're nice and funny.
Oh,
We
that's.
could have a roof.
Yeah, at least no one knows.
Not a capable teacher, but he's nice and funny.
We can't really blame you since it's your first time teaching.
That's
Yeah.
very sweet.
And you said that you might buy a
Michaela saw, I did have the chocolates. I witnessed, but there weren't that many, so I started eating them. Sorry.
You ate our chocolate.
No, they're there still, some of them. Some of them are,
Rude. I take back my next statement.
Sorry. Like this. Okay, all right, so we have this many tests. I'm just gonna, actually, now that I have it, I'm gonna copy it because I don't wanna. All right. So what do we want to do? We want to fill out the schedule. And okay, so let's do the way I recommend doing a problem like this. Okay, there's 2 steps I would say, in kind of a hard math problem. You guys are used to, I think, mostly one-step problems because they're mostly computational. I mean, anyone up through like differential equations is used to this. I'm not saying you guys, I'm saying like pre-proof math. Most problems are just like apply an algorithm, right? Here's a way of doing something, do it. And you just apply it. However, a lot of problems you want to kind of do a couple of things. Like if it's a hard problem, you want to do it in two steps. So the first step I recommend you performing is to try an example. Try an example first. That's not the solution to a problem like this, but it will give you an idea of how to get the solution. Okay. So when I look at this problem, first of all, they gave a hint. They gave a hint that said, try to break it down into cases where you look at the remainder after dividing by 6, where in other words, you look at the remainder of n after dividing by 6. The simplest example for me would be to look for a remainder of 0 after dividing by 6. And I would look at that example first and try to make an optimal schedule for that case. Okay, so for that, we can write down the tasks. I'll write them like P1. I don't know, 2, P3. Okay, so I have 6 of them, right? Now, I'm gonna just here from. So we need to make this schedule. Like it does. Serious. Give me a square. Okay. Okay. Good. So how are we going to do this, guys? What's the optimal way for 6? That's the first step. And then you'll see how to do it in general. I'm sorry? So if you're saying to put this guy in the top,
Yeah.
So you fill in this,
Yeah.
And then what? Any other, I mean, we can start there, that's okay. Leave her on the limb. So one thing you could try to do is just do like a decreasing time algorithm. I mean, right? If you wanted, why not? I mean, you would be going this direction with a priority list. Okay. I don't know, see what happens. Okay, so here's our first task. You know what I'm going to do? I've got an idea. I don't have to work hard. Let's give this a border. Look at that. Okay, now we can distinguish the tests. All right. We'll do one with 6. Then we'll do one with 5. Okay, and then we have the first available one we can assign for 3. So I'll make it 3 first. Next available one we'll make for 2. Last one. How's it look, guys? The schedule. Looks pretty good. Do you think you can do better than that?
Since you're asking for all that.
Really? Is everyone, how do you, yeah, why don't you think, I'm sorry, what's your name? I should know all your names by now. I don't know.
If you could guess.
Chris. Okay, Chris, I'm gonna learn, now there's only like 6 people here. I can learn all your names. I think. Okay. Chris, why is it optimal? Why can't we do better?
They're all even.
You mean they're all the same number?
Yeah.
Uh-huh.
I just don't see how there's one possible way.
Yeah, I mean, I think your recognition that they're all sort of the same. Yeah, if you have, what's the total here? It's 21, right? Like, if we look at the total amount of time, and 21 divided by 3 is 7. And so if you make it so that everyone's always working all the time and you get all done at the same time, that's got to be optimal, right? You can't, you know, sort of the non-optimal ones, people will be idle for some amount of time. So this is definitely optimal. This looked good. But when you look at this, I think you can kind of start seeing a little bit of a pattern here of saying, hey, you know, I've got this kind of staircase thing going here. Or you could say, you know, who did I assign to processor 1? The last and the first. Who did I assign to processor 2? The second to last, right? And so on. Kind of bracketing it in. So you could think, okay, that's kind of an interesting thing. Maybe we can try doing that. And indeed, so now if we added one more task, I chose P, I should have chosen T here. Anyway, whatever. Task. Can I keep the schedule and just add a times 7 on there and get something? I'm saying now. She's right. I can't. Well, that, I mean, if I did that right, I would be like, this would be my schedule, right? It would be pretty long, right? I mean, I'd have to 7, just out here somewhere. I mean, I can do it. It's a legitimate schedule, but it's kind of, it looks like there's a lot of idle time, right?
That's really make 2 people.
So can we redo this in a sense?
This one first.
Any questions?
Well, I mean, what would be ideal here, I would say, is so what's our total processing time before was 27, right? Or 21, excuse me. And now we added 7, so now we have 28. Now what is 28 divided by 3? My elementary ed. Killing me here.
Don't say it.
I'm not even gonna guess.
Well, it'd be bad.
You're not gonna guess 28 divided by 3? Oh, come on. You are teaching, luckily my children are already old enough. You might be teaching someone else's children.
2.625.
It's okay. I'll write it by then.
What happened?
Okay, so 3 goes
Oh,
into
you're hurting my
28.
feelings here, guys.
3 goes into 28 9 times.
9, right, so it's 9 with, well, I'm just looking for remainders here. You can give me a remainder. You're gonna be teaching a lot of stuff with remainders, which is fine. So, yeah, 9 times 3 is
Or I'm the only one that can-
27, so you get a remainder of 1. So it's about 3, it's 3 1/3, right? Okay. So, but 3 with remainder of 1. So what you would like to do is, since you're defining, assigning all of these tasks to 3 processors, you would like to say, I'm going to give each of them at least 9 hours of task time. And then you have 1 left over, right? To assign to any one of them. That would be optimal. That's the sort of the best you. There you go. So instead of assigning these 2 and then these 2 and so on, just bump it up. Assign these 2 then assign these two, then assign, these guys. And each of those will add up to 9. And then you'll have one task left over and you can assign that to whoever you want. Right? Does that make sense?
Can you draw it out?
Sure. Try. I just like be clever here. I can be clever. I can be clever. So I guess this would be okay. Okay. That's why I get paid the big bucks. Not so big. All right. Say brought home the bacon bits. All right.
Hell,
Don't complain. You don't have children. You don't get to complain until you have children.
I do technically.
You do it.
You are my own children. You are my own children. Like.
Mostly but self-responsible.
I guess I shouldn't assume that. I mean, but yeah, you could. It's okay. All right.
To bed?
All right.
Okay, sorry.
Are we all good, guys? All right. So if you like this experience, come Mondays at 3:30. We will have many more experiences just like this. Okay. I won't grade like harshly on this. I mean, it was a harder problem. I'll get that. So people don't worry about that. All right. So back to where we were. So we were talking about statistics. We're in chapter 14.
Could I ask something about the exam?
So section 14.2 deals with measurement. Again, I'm not sure what to say, so I would recommend reading this. They have a lot of examples of statistical studies that they talk about, and how essentially enumerating what they're looking, whatever they're looking for, can fail, or how if you have a sampling. Oh, is it okay?
Jenna had a question.
Oh, Jenna. Sorry. Jenna asks, what's up? Thank you.
Question 1 just was kind of a choppy
I asked something about
explanation.
exam. Yeah. It's freedom. Go ahead, ask away. What do you want to ask, Jenna? The first question was confusing. That's not a question. That's a statement.
Well.
Said at 13 bridges, only added up to 12. So I think it said that there are 13 bridges, of which a certain number are the ones that I wanted to cross. I thought that's how I wrote it, but let's take a look. I'll see if I can explain it. But if I miswrote it, I can make the correction. Where are you guys? All right. So if. Oh, it's, yeah, I have an and the. Sorry, maybe that's why it looks so horrible. So the and the shouldn't be there. It should be and, yeah, it should be and the state of New York. The mainland state of New York. I couldn't really, I don't know how to say that, but it's the state, I mean, Long Island's New York too. So I didn't want to like say, make a statement. This should be and the mainland state of New York. There are 13 bridges between Manhattan and the mainland side, state of New York, and she wants, out of those, she wants to visit 5 out of those bridges. If you look at a map of Manhattan, New York, right? There are a lot of bridges. There's a little river, right? There's a lot of bridges to mainland New York. And then there's some to Long Island, and then there's some to New Jersey. There are also some from Long Island to New Jersey, but we're not, I mean, anyway. Not Long Island to the state. Anyway, so the 12 that I'm referring to concerns these. I've got these 3 bridges here. What am I saying? Where do I say 12?
It says she added it up.
She wants to visit 5, 3, 6, and 3. She wants to visit these 5, the 3 here, the 6 here, and the 3 here. So that would be 17 that she wants to visit. So she wants to visit those. So ignore the 13. The 13 is just for your edification. I was looking at a map of them and I'm like, if I were a photographer woman, which one would I want to? No, I didn't think about the woman part, but I thought about if I were a photographer, where would I want to visit? I saw 5 that looked good. I didn't really do that. Does it make sense now? Jenna? Thank you. Okay. Yeah, I'll go in and I'm sorry about the and the part. I'll go in and deal with it. So you don't want to see what that really looks like. Yeah, oops. If you go, if you go to, I mean, most of this is coded, like the exam itself in a different, in the language called tech. So it's sometimes when it translates, I've not edited it well. So sorry, I usually try to look, but I missed that. I'll fix that, but hopefully that's clear. Okay, guys. Survey. All right, so measurement, what we're going to focus mostly on is surveys rather than the censuses we talked about last time. Those are more interesting from a statistical standpoint, or mathematical standpoint. And they say, okay, there's like 3 steps in making a survey. One is in choosing a sample. I agree with that. 2 is in measuring how you actually measure whatever you're like, and then 3 is making some inference. This is their 3-step statement. And then they get into this whole discussion, which is a very interesting discussion. Everyone should be aware of this. I definitely agree. So when I say I'm not qualified to teach this, I'm not saying it's like not interesting or important. It is like very interesting and important. And especially because it can be used very seriously against you in your life to miseducate or whatever. And so they talk about something called selection bias. Who knows what that is? Does anyone know? Yeah.
You see a lot on the side like say these people don't like the current president. Well,
Exactly, right. If you're going to do a survey, that's a good example of like, who are you going to vote for in the next election? And you go to, you know, like, yeah, you could go to like a bunch of union halls right? And like take a survey, although nowadays, I don't know if you could find one, but you could try. Or you could go to a bunch of, you know, like retirement homes, you know, and take a survey. If you would probably get very different results, right? And so that would be like, you're not choosing very good representative sample if you do either of those things. And you're selecting. So, but that's an example where it's intentional. There are plenty of like unintentional ones. So one that I would say would be like really a good example. So last time we talked about like defective apples. So let's say you were going to make we talked about choosing a sample out of like, you have a factory, it's making a certain number of apples. And then you say, let's say you go to the factory line, the belt or whatever that's churning out your apples. And let's say you pick out every fourth apple. So if you pick every those are examples of selection bias. Now, the thing about it is a lot of the processes. So now let's say you find, that, none are defective at all. Or you find that, all of them are defective, right? Something like that. You get an extreme representative and then you make your inference and you say, well, that must mean everything is defective or there are 0 defective units. So what could be happening there? You could be very wrong. And the reason that you could be very wrong is what? Do you guys have any thought of that? I mean, one thing that happens frequently is if you're used to coding, you run into these types of problems, which is that somewhere earlier in your process, you divided things up evenly, and then you brought it together. So let's say somewhere earlier in this factory line, you had 2 machines that were, or 4 machines, say, that were stamping a certain type of microchip in. One of them was defective, but then when they assembled, that was happening, 1 out of every 4, and you were sampling only the ones that were off of that pattern. Yeah, you could have like, one of them could have, so you're just missing like a component of your process by just selecting every 4th. So instead, what you should do is sort of randomly select the remainder or something, divided by 4. It shouldn't just be whatever. You shouldn't get into any kind of pattern, because then you're not going to get a good representative sample. So this is a non-intentional one. I'm kind of, as I said, I have strong opinions of politics, but I won't say any of them. But I will say there are a lot of examples of so I think like an election is sort of like a survey. I mean, you're essentially trying to gather the opinion, the majority opinion in any sort of representative body. But there's all kinds of ways of screwing that up intentionally, right? There's ways of actually, intentionally sabotaging that, which are historically done by both parties in this country, and kind of interesting. So I thought I would give an example of that.
This county to survey in Kansas is Southern County because it's spread it's very systematic.
Well, my prediction based on is that it will go red again. The reason it will go red again is because the red party is in control right now, and they are redistricting as they are across the country. It's time to do that, and they will do that in their interest, as all parties do. Now, this is what I want to talk about: is how do you gerrymander? What does it mean? You guys know how this works?
Gerrymandering is where you have to have a certain number of people in each district, about 100,000 or so.
Uh-huh.
But you cut out this county because it's more liberal, so add a conservative county to represent this.
I would say it's a little more. I'm going to give you an example to explain exactly how it works. The idea is idea is to subvert the majority rule or consensus opinion. That is the idea. It is anti-democratic to do this, what both parties do. And it really should be, there should be, in my opinion, checks against this. It's really against the basic principles we have. However, it is done by both. It's hard to actually, it would be very hard actually to make a law to avoid doing this, because you would have to somehow infer intent. Sometimes it's pretty clear. So let's say we're in land of professor can talk about politics. And there's two parties in this land. In this land, party A has 70 individuals that are strong adherents to the philosophy of party A. And party B has 50 adherents. So if we were in a very nice democratic society here in this world, party A would generally win, would be able to make policy, let's say, which is okay. However, in this world, there are 3 districts. And this is not a democracy, just like we do not live in a democracy. We live in a representative democracy. That word representative really changes the meaning of democracy. It really has a mathematical effect on how democracy works. It is not generally consensus unless you make laws to really enforce that. So B is in control 1 year, and they want to draw the maps. So they do draw the maps of the 3 districts. And when they draw the maps of the districts, District 1 has 34, whoa. Sorry. Has 34 A citizens drawn in and 6 B citizens. District 2 has 18 A citizens and 22 B citizens. And District 3 has 22 B citizens and 18 A citizens. And then they have their election. And look what happens. You see what happens? So who wins? Party A wins by an overwhelming landslide in District 1. However, in Districts 2 and 3, Party B is in control. And they have a 2/3 majority. And they are able to create all policy. So in this land where you have actually a very sizable majority in Party A, Party B still rules. And that is really due to the 2 factors. One, the ability for those in their Party B to draw their own maps, but also 2, that there's a representative democracy. And that really does change how things work. So I think it's actually worth being aware of how this works. And seeing it in practice, and we will see it in practice. It's already happening right now in Kansas and actually in other places.
Kansas is a bad look at Texas.
There are egregious examples where you can really clearly see the intent, but then there are examples where it's harder. And there are, you know what, having met and worked with a lot of politicians in my life, there are some that are actually good people that don't want to do this. On both sides, I've met people on both sides that are very just good people and want to do the right thing and preserve the right idea. I'm cynical, but there's some people that don't. But there are professionals that design this stuff. This is not like done by these politicians' offices. Okay. So math, I mean, in general, and statistics especially, can be used, very inappropriately. The results if you ever hear anything that says statistics say this, or, this many out of this many people think this, you should be skeptical, like generally skeptical of that. Selection bias really does play into that. A lot of these studies are not legitimate. And so I think it's good to kind of keep an open mind about that with whatever you're listening to. So then they go through a bunch of sampling techniques. And they talk about convenient sampling. I don't know what to say about that. There's like no math at all in that. They just explain how it does result in a lot of selection bias. They call it often self-selection bias. So like a convenient sampling is like you conduct a survey, but it's best to do it just where you are. Like I pull you guys. Like I want a good sense of what's going on with all the students in K-State. So I'm going to just pull you guys and ask you guys, and then I'll extrapolate that to everybody in the entire population. That's convenient sampling, and that's clearly biased because you all share a commonality of being in this class, for example, which is not shared by a lot of people. So much less, there's a lot of other things you could point to. So that's an example where you avoid a cost with whatever survey you're conducting, but it's not a very good survey. There's this notion of quota sampling. And here the idea is you select based on predetermined proportions. So your sample is selected based on a predetermined proportions. So let's say I know that there are 60% of the student body is female and 50% male. Okay, or 60 and 40. Thereabouts, plus or minus whatever wiggle room you want to put in there. And then I decide that I look at my class, I'm like, okay, this is not representative. And so what I'll do is I'll go grab a couple of guys out of the hall and make the proportions match the proportion of the school. So that clearly will still be biased because it's not, I'm not addressing some of the factors that it's very hard to get all the proportions right, I guess, at the end of the day. And so this sort of forced quotas that you would have on whatever groups that you have, this can result in sort of not randomly picking people and therefore having some selection bias in that sense. So there's also, I think, a mathematical reason, which is you guys are familiar with Venn diagrams and these kinds of things. Whenever you do proportions, there is a lot of overlap in some of these categories. And if you don't have that numerically correct, you're going to get your proportions way off. And it can become kind of complicated if you have a large number of quotas, large number of variables. All right. What else? Oh, okay. And then there's random sampling, which I think is kind of the best, but it can be kind of difficult. Where you just have a large population and you can somehow randomly find a technique to randomly sample the entire population. If it's truly random, then this will kind of accomplish the quotas and everything like that in the right way. Okay. That's essentially it. There's a lot of examples in this section. That's essentially all there is. So what I want you guys to do, instead of me assigning homework from chapter 14, is I want you to read chapter 14. Okay, could you do that? I mean, I think it's worth doing, and it's worth, in a sense, getting some of the language down for this section, this chapter, because you will see it like in your life. But we'll I'll finish up a little bit on 14.3 next week, and then we'll move on to the next chapter. There's a little more math. All right, guys. We'll end a little early today. Yep.
What if you say on random sampling that?
Hmm?
Random sampling is probably not the best when it comes to like